like in school, is you post the test and the answers.
Yeah.
Why not?
I thought you want us to succeed.
That's right. I am here for you.
Completely forget.
Okay, so the test is, where did my cheat sheet go? 23 multiple choice questions. That's my lunch duty behind there. You don't need that. 23 multiple choice questions at 3 points each. That makes 69 without a calculator. Look at me go. And then there are 5 free response questions. But you guys are junior. Free response questions usually means like a lengthy. These are not lengthy questions. These are the easiest ones, really. There's 5 of them. I just don't want you to think that they're really a long question. They're pretty easy. There are 4 points each. So that makes 20. That's a total of 89, which means you could literally miss everything on the test and make an 11. Congratulations. So it's sort of a curve, but it's not an 11-point curve. It's like a sort of a bottom end curve.
It's a base.
Yes, it's a floor. You will not make lower than an 11 on this test.
Unless you don't write
There
your
you
name,
go.
you get a pass.
That's right. Yes, your name is worth 11 points. How about that? There you go. That gets us to an even 100.
There you go.
If I can't read your name, then maybe I'll take off 11. Those 5 free response questions, told the other group, it's evaluating functions given a graph. It's supposed to be easy, but man, people just mess it up. Looking for an example. So like this is worksheet 1, and flip it over to worksheet 1. That first graph. If I ask you to find f of, let's do f of 3. How about that? Oh, y'all don't have that handy, do you? Because it's f of 3 is what? Oh, I picked a weird one, did I? F of 3 is 2. F of 2 is 2.5. So yes, you are correct. Stuff like that. That's supposed to be easy. You're supposed to be able to look at a graph and know x's and y's. Know that the x is in parentheses, so go to the x value. That should be the easiest 20 points on the test. I'll throw things at you if you miss something from that section.
Where is that question?
I just made that one up based on a graph. Okay, so there's your 100-point test, provided you know your name. I'll just put this at the beginning of each video. So for third period, I did 1, 4, 7, 10. For fourth period, I'll do 2, 5, 8. And then for sixth period, I'll do 3, 6, 9. By the end of the day, I'll need to do just multiples of 3 because my brain will be fried. I'll save the easier for last. All right, so we're starting with number 2. Again, the biggest challenge today is for me to make sure I do every third one and not do every second one somewhere down the road. All right, number 2. The table describes rates of change of f. Rate of change. Rate of change. That's average rate of change of slopes. So I'm going to say rate of change is like sort of like slope. Rate of change of a function f on selected intervals. The function f is defined for 0 to 4. Okay, that's why we got 4 intervals, 0 to 4. On which of the following intervals is the graph of f concave down? Let's see. The rate of change is increasing. So that means the slope is increasing. So I need to draw something with an increasing slope. So not just a positive slope, but an increasing slope. So if I start out like small positive slope, then it gets bigger and bigger and bigger slope. So what is that in terms of concavity?
Concave up.
That's concave up. So that's not it. Rate of change is positive and constant. So the slope is positive but constant. Something like that. This is kind of a trick question. Is that concave up or concave down? Neither. That's neither one. Concave down is the frown, concave up is the smile. That's a straight face there. Slope is decreasing. Slope is decreasing. So even if it starts positive, it gets less positive and then 0 and then starts going negative. So yeah, that's concave down. So I think that's the one we're looking for. Negative and constant, just to verify, I'm pretty sure it's C, but negative and constant would look like that. So yeah, that's not concave down. So it's C. So I like those kind of questions. Concept questions. Didn't have to do any, it's all math, but it wasn't computations. Number 5. Oh, water is poured into a vase, or vase if it's fancy, right? The only difference is how fancy it is. Water is poured into an empty vase at a constant rate. A graph, not shown, thank you for that, models the depth of the water in the vase over time. The graph can be described as follows. The graph is always increasing. Okay, so if I'm pouring water into a vase, the height is always increasing. Okay, yes, I don't think that helps me. I assume I'm picking the vase here. The first portion of the graph is clearly concave up. I think I'm going to try to sketch what it says here. It's clearly concave up. The next portion of the graph has a fairly steady and steep increase. Steady and steep. So we're going to go concave up, steep increase. Which of the following is appropriate for the context described? So concave up, and then steady and steep increase. Okay, so which one of those vases or vases would have that graph? If I steadily poured water in, which one of those heights would look like that? Well, the first thing I think I notice is that it probably can only have 2 sections to it. I feel like C has 3 sections to it. Because I think this is going to be concave down up to there. Because it's increasing, but it's not increasing it's increasing at a slower rate because it's getting wider. So I think I need it to be getting narrower to start with. That way my height will be increasing faster. So I need it to be getting narrower to start with, which goes to A and B. But then I need it to be steady at the top, that would be concave down. So I think it's B. Okay, 5 plus 3 is 8. Number 8. Well, somebody was asking about this. Maybe that was last period, though. Number 8. The table gives the value of the function for selected values of x. The function f is linear. What is the value of f of 13? So I'm just going to add my own addition to the table there. Well, I'm thinking I just write the equation of a line and then plug in 13. Like I was looking for a pattern to get there. Right, that's a difference of 6. X difference of 6, Y difference of 8. X difference of 3, Y difference of 4. That matches. So I found my slope. Actually, I did find my slope. Sort of backed into my slope. What's my slope equal to? Not 4. It's got to be change in y over change in x. So change in y over change in x. So 4/3 or 8/6, which is 4/3. And then, so, a couple ways to do it. Do you know the point slope form of a line? That to me is the easiest way to do it. Y minus y1 equals slope times x minus x1. Yeah, you probably have. It's just been a while. The other thing is to just say if I'm starting at 2, if I'm starting at 2 and I'm going 7 away and my slope is 4/3, could do it like that. That would land me there. Because my x difference is 7.
Oh, yeah.
And so my y difference is 7 times 4/3, whatever that is. I don't know if that's the best way to get there. I'm going to go back and do it this way. I can use any point I want. I'm going to use 6 and 2. So y minus 2 equals 4/3 x minus 6. And then I'll plug in 13. So y equals 4/3 times 7 plus 2, which just happens to be what we did if we just kind of figured it out. I plugged in 13 right there, sorry. So 28/3 plus 6/3, 34/3.
Oh. You gotta do it with that one.
What? Feels like you get but you're wasting that.
Questions? That's kind of a tricky one because it didn't land in a nice spot. Number 11. The graph of the function is given of the following. On which interval is the average rate of change, slope, the least? The least. So that means, well, we'll see, which is the least. So -3 to -2. What's the slope from -3 to -2? Let's just eyeball them first and see if we get a clear answer here. So the slope, the average slope from -3 to -2 is 4.5. Roughly. We'll see if this is good enough, this roughly stuff. From -1 to 0, the slope is -2.5, because we're going down, so -2.5. From 1 to 2, they were kind of, all of these have a spacing of 1, so I don't have to divide by anything. So my change in y over change in x from 1 to 2 is -1. And then my change in y over change in x from 3 to 4. 3 to 4 is maybe 0, maybe -0.5. So which one of those is the least? -2.5. And that makes sense. That's a fairly negative slope part of the graph. Number 14. 11 plus 3 is 14. Uh-oh, here we go. Now we get some good stuff going on here.
Wait, I thought we were going to do like a
We're doing every third one, starting with number 2. So we're doing problems 2 plus 3n. How about that? An object is moving in a straight line from a starting point. The distance in meters from the starting point is given in the table. If the pattern is consistent, okay, well I like that. Which of the following statements about the rate of change of distance over time is true? So I think I have to do like a second order rate of change. Okay, so let's see. This first rate of change is 8 divided by 2 is 4. Are you okay with that? Change in y over change in x. Or in this case, change in meters over change in seconds. This rate of change is 12 divided by 3 is 4. And then this rate of change is 20 divided by 5, which is 4. Okay, so the rate of change is a constant 4. That sounds weird to say. The rate of change is always 4. So that means the rate of change of the rate of change, distance over time. So that means the rate of change of a constant 4. So the rate of change of the rates of change, it's not changing, so it's 0. Uh-oh, but I got to worry about units here. So is it meters or is it meters per second per second? You guys are in physics right now, most of you. Are you probably in the midst of position, velocity, acceleration? Just the very beginning of it?
Yesterday was our first day of minutes.
Velocity is change in distance over time?
Yeah.
Yes? What's acceleration?
Something distance 0. No wait, no.
Nah, don't give me some crazy formula.
It's like
Change in velocity over change in time.
Yeah, that's what I'm saying.
So it's like a second order change thing.
What was that?
So this is meters per second per second. We found acceleration.
Something's
So the first rate of change is a constant 4,
Would that be on the test?
but the rate of change of the rate of change is 0.
Like 10 minutes.
If it's on the test, it's not going to include this unit difference thing because that's really more physics related. Basically, it asks us to find acceleration, but you guys don't know acceleration yet. I mean, but it didn't say acceleration. It just said rate of change of the rate of change. It just forced you into doing a second order difference problem. A second difference.
Wait, so it's per second per second?
Yes,
Per second per second?
because it's a second difference. Number 17. The function f has a domain, -2 to 2, and a range 1 to 5. The function g is given by, oh boy, this is going to be interesting, -f of x plus 3 plus 4. Okay, so let's not worry about domain and range yet. Let's talk about what each of these things does. So the negative out front, what's the negative out front do? Flips it up and down. Plus 3 will be left 3, and plus 4 will be up 4. Alright, I think the trickiest one, so like the up and down and the flip, those are going to affect the range. Those are going to affect the range. We'll have to flip it and then move it up 4. I think the easier one to handle would be this left 3 because that would affect the domain. So the domain used to be -2 to 2. But if I go left 3, that means I need to back up 3 on both of those. So -5 to -1 is my new domain. And so, whoops, I shouldn't have circled A or B. It's one of those two. My range, the original was 1 to 5. If I flip it over, well, I'll just multiply them by negative. That would work. So -1 to -5. That seems a little bit weird because that's out of order. But -5 to -1. And then I need to add 4 to everybody. That would be -1 to 3. Hope that's an answer choice. It is. That was tricky. You had to use your combination of things, your parent function transformations, and then apply that to domain and range. That's weird. Hey, sign up for BC, you get weird problems, right? Apparently so. Nobody told me that.
This is supposed to be, that's AP. We're in advance, not in AP.
Again, let me do 3 away from 17 is 20. Number 20. Then I'll answer whatever questions you like. No, I won't because we won't have time. Number 20. The table gives values for a polynomial function. Uh-oh, we got this parent function thing going on here. G of x equals a times f of bx plus c. In the xy plane, the graph of g is constructed by applying the 3 transformations of f. Okay, so now it's telling us what this is. A horizontal dilation by a factor of 2. Oh, that's the worst. So if I want to horizontally dilate by 2, what is v going to be? 1/2. That's the tricky one. It's probably the worst one. A vertical dilation by a factor of 3. So that means the 3 goes up front. And a vertical translation by 5 units upward. So plus 5. And we want to know what is g of -4. But let me slow down. Are you okay with this line? Because I think it gets easier from here, especially that 1/2. Right? Dilation is the word that describes what happens to the graph. So if it gets dilated by 2, it grew by 2, but because the x stuff is backwards, that means there was a 1/2 x in parentheses. You guys are not as vocal as last period. You're not as challenging and questioning.
I'm trying to read it.
No, you're challenging in a different way, Dylan. Congrats.
Dylan.
You're not Dylan. You're
It's fine. Keep it.
Marcus.
I see where I rank in your hierarchy of names.
And that's recorded and posted now, so okay. All right, are you okay with that? I'm not worried about the 3 and the 5. It's the 1/2 is the tricky one. F of 4 means, or -4, means we put -4 in for x and see what happens. So 3 times f of -2 plus 5. How do I know what f of -2 is? Look at the table. So there's a whole bunch of extraneous information up there. What I need to know is that f of -2 is equal to 5. So 3 times 5 plus 5. I sure hope 20 is an answer choice. And what do you know? Feel better about that. Sorry. Better?